First, we're thinking with what? I don't even finding extrema. What does extrema mean? It's just a maximum or a minimum. It's the extremes. So, it's plural. Extrema is plural. Extremes is also plural. I'm confused with that, but I don't care. So finding extrema just means we're going to find the max or the min. And yeah, let's see. We found yesterday when we were doing stuff from a graph, finding extrema from a graph, if the function was continuous, then extrema occur at turning points. So you can write that down. So if the function occurs, if your function is continuous, then it occurs at turning points. If your function is not continuous, then you can have relative extrema. Like maybe yesterday, you don't have to write this, but yesterday we saw something where it was not continuous, and then we have something like that. I guess that's still a turning point, but we also had some like this, where it had an open circle and then maybe a closed circle there, and then a closed circle going like that. That's this part is a relative minimum. It's also an absolute minimum, and it's not occurring at a turning point. But you would have to just check any points of discontinuity if your function is not continuous. So what we're going to be dealing with mostly are continuous functions or smooth functions, not piecewise functions. So we're going to be dealing with something that's smooth, maybe like this. It's not a sine graph. So if we have something that's smooth like this, we just need to find out when the function turns around, because those are the turning points. Here, right? It's going up and then it's going down, and it's going down and it's going up, and it's going up and then it's going down. Here, algebraically, we can find out the turning points just by looking at the slope, right? If the slope goes from positive to negative, that means the function has turned, going from increasing to decreasing. That's the same as like the particles. What? If the particle turns around, same with the function. It'll show that with a turning point. So, what? To find relative maximums or minimums, you do a sign chart and you see where the function turns, where the function turns. So, let's write that down real quick. So to find a local or relative extrema, you get the derivative and make a sign chart. So if your function goes from increasing, meaning positive derivative, I'll write that, positive, decreasing, negative derivative, that would look like going up and then going back down. That's a turning point. If you have increasing to decreasing, this corresponds to a relative maximum. And if you have it the other way around, going from decreasing, which means negative derivative, to increasing, positive derivative, then of course it's going to be a relative minimum. So those are really the rules. Yeah, and then you just check your endpoints maybe and see if you have any absolute maximum or minimums. So yeah. I'll show you what I mean when I say check the endpoints for your intervals. Oh, did I say that? I don't even know if I said that. It might have been paused. To find any absolute maximum or minimums, you just see which one has the highest y value, which relative extrema have the highest y values, and then also check your endpoints, because you could have absolute maximums or minimums at endpoints as well. And I'll show you what I mean with an example. So let's see here. Actually, I'm going to do the example in another video. So there we go.